Now let's say if two strings are anagram of each other. That basically means they have the same characters, but in different sequences. For example, ABCD and CBDA are anagrams of each other because they have the exact same characters, but in different orders. Again, this is another very popular interview question. Now, there are a couple of different ways to solve this problem. In this video, we're going to look at one solution, and we'll look at another solution in the next video. So here's the simplest way to solve this problem. We convert each string to a character array. So for the first string, we'll get A, B, C, and D. And for the second string, we'll get C, B, D, and A. Then we sort these arrays, so this will become A, B, C, D as well. And finally, we compare these arrays for equality. As simple as that. So let's add a new method, public static boolean r anagrams. Here we need two parameters, first and second. So we get the first string, convert it to a character array, and store the result in array 1. Now we can sort this array by calling arrays.sort. We should repeat the same steps with the second string. So second to char array, we store the result over here, and then sort this array. Good. Finally, we call arrays.equals and pass array 1 and array 2, and finally return the result. Really easy. Let's test our solution. So here in the main class, we call string utils, our anagrams, we pass ABCD and DBCA. We get the result and then print it on the console. So we get true. Beautiful. What if we add one extra character here? We get false. What if we replace one of these characters with something else? We get false as well. So far, so good. What if one of these characters is in lowercase? Now we get false. So this is one of those areas that you need to check with the interviewer. You need to ask if your solution has to be case insensitive. Let's imagine the interviewer says the solution should be case insensitive. So we go back to our implementation. Before converting the string to a character array, first we convert it to lowercase, and we do the same with the second string. This will solve the problem. Now these two strings are anagrams of each other. What if we replace one of the strings with a white space? We get false. How about an empty string? We get false as well. What if we replace it with null? We get a null pointer exception. So before we do anything, we have to check to see if the first or second strings are null. So if first equals null or second equals null, then we're going to return false. That's better. So this is one way to solve this problem. Now, a tiny optimization here. Let's imagine that the first or second strings each can be 1,000,000 characters long. In that case, converting these strings to lowercase, then to a character array, and finally sorting them is going to be a little bit costly. Now, before we do any of these, we want to make sure that these strings have the exact same length. If they don't, they're definitely not an anagram of each other. So there's no point converting them to lowercase, a character array, and then sorting them. So we're going to extend this expression by adding another condition. If first.length does not equal to second.length, then we're going to return false immediately. As you know, we can read the length of a string in constant time. That's an O of 1 operation. So this is how we can optimize this method. Now remember that I added this code, this extra code, because I assumed that the first or second strings can be millions of characters long. If they're not, if they're only a few hundred or a few thousand characters long, we don't really need to add this extra code over here, especially if this code is not going to be executed a lot. Let's say it's going to be executed once in a while. So we don't really need to optimize it. There is an old saying by a famous computer scientist, premature optimization is the root of all evils. I cannot agree more, because quite often, optimizing code affects its readability and maintainability. In this case, adding this extra condition is not a big deal. It didn't really affect our code a lot, but if you remove it, you can clearly see that our code is cleaner and easier to read. So before optimizing your code, always take the context into account. See if you're really dealing with a large input or a lot of load on your application. Ask the business, is this code going to be executed hundreds or thousands of times every day? If not, you don't really need to optimize this code at the cost of affecting its maintainability. So if you're going for a coding interview, always ask the interviewer about the size of the input so you know what kind of problem you're dealing with. And that's what separates a software engineer from what we call a code monkey. That's someone who just writes code without really understanding what they're doing, without understanding the problem. A software engineer is one who develops properly engineered solutions to today's problems, not tomorrow's problems that may never happen. I want you to be a software engineer, not a code monkey. All right, in the next video, we're going to look at another way to solve this problem.